So today is a little bit different. I have given a talk to a meetup. Have you guys attended a meetup meeting? So there is like a community for meetups for different topics, and I have went to like a Rust NYC meetup, September 26th. So there's a like engineers and people and different basically professionals to go and interested in like programming language like Rust. So I've given a talk about this application. So it serves as an overview of this application and some of the structures and design decisions and why I'm doing this. I think I also haven't introduced um, myself in some of things. So this one I'm trying to do the slides, and you may get a better overview of what's actually the high level, what's the component, what's the thing behind it. So don't worry about if it's like you think so is give you um, too much information, but it gives you like an index to search and a reference. So this is my bio. I am a data engineer. So I studied biology, physics, and computer science like about 10 years ago, and then I'm doing front-end development. Like, yeah. So I'm trying to remake a slides, the video I'm giving a talk, to give you like a high-level overview of the application and some of the decisions and design decisions and motivations behind it. So what is this application? So currently it's a bookmark application. There is a website that codes, and it's called a decentralized cross-platform. So we have different components, browser extension, desktop and mobile. It's my kind of spare time last June. So why I'm doing this? So actually there is a good reason for performance. So you already tried like on your phone. If you type ahead for the search, it's actually faster than you do like an online search because there's no network and delays. Also, if you're just like a single user, it's much easier to design. So currently, all the application you use, mostly likely you need to log in and go through a web server and download information, upload information. So this one actually don't go through the network. It directly works on your device. And then there is probably the most important one is like privacy. So people are aware of their data. Our generation, kind of the technical people know this issue, but we're kind of doing something. But hopefully next generation, especially like you guys, will feel it more. And there are some laws is coming. So like how to collect data, how to use the data is become a real thing, hopefully, when people are all aware of this. So how this is done? Most of this is through Rust as a core library. So this is the programming language. So we'll get into that. And it's basically a command pattern. So I'm actually showing some code. So everything you do, like you adding a record or delete a record or search a record, search the bookmarks, it actually goes through a text into the Rust library, and it responds with a Rust library. So you see those match statement. So if you match like a command saying it's an upgrade command, it's an insert command, or it's a delete command, it's a select command, it's a search command, it's a filter command. Basically, those translate to things like I'm doing like a filter. So those are commands issued into the program, and it come out as a string, as a JSON string. So at the Rust level, it's a command requested respond in JSON format. The counter example is like some companies like Airbnb and Dropbox, they abandoned the native binary approach because they still stick to the main developer tools. Like I think it's considered in team environments, and also the recruiting technical talent related to those factors. And then it's about the code storage is SQLite database, which is a proven public code base. We'll talk about the visualization, like how the graphs and tags is working, and how to upgrade from different versions, and the syncing. So you can actually sync between your device if your device is on the same node network. So for the browser extension, like when you click so to demo this, so if I click this extension, if you install it, you type your keyword, let's say NYC, and enter. It create a record for this, and timestamp become the first one. And when you search, it do mostly like a full text search in those record, and you can actually like delete, it goes away. So this is the browser extension. So you install it from the browser store. So this browser extension handles std in and std out. Basically means like you input something to the extension as the binary is a program, and it then outputs a text as a response. So the extension based on this input and output. So the program looks like this. So you have a main program, you have the std in as, then you convert this to some kind of string. That string basically becomes those commands. After it processing, so the actual command is the response. So this is a statement for saying, I'm running a command as a text, run this command. The response becomes a response. Then the response is sent back to the extension. So this is a send function, and it is it's writing out to std out. All those programs, like the mobile application, the desktop application, and extension, share the same library, so they reuse most of the code to manipulate the database. So that's why you can actually share the same. It's kind of the same application. You can actually, if you sync the data, they can share the same data. For browser extension to work, you need some kind of thing called a manifest. This is different by systems. Like Windows is at different locations. Linux has different locations. This is like in Linux locations, at this path, there is a configuration file to locate the binary for your extension. So afterwards, when we get your code installed and trying to compile them, like this path will be the binary you compiled. So this is like a template path, is an example path for the extension. Once we get there, like when you get Git working, when you compile your code, this is the path is where you locate your binary or executables for your programs for the extension. So this is Firefox example, this is a Chrome example. They're very similar, with a little bit difference. Firefox and Chrome actually share a lot of the same code. For extensions, they are kind of standardized their extension protocols. For desktop application, I already showed like this one. It's using a framework called Electron. So that's a framework to build a desktop application. Their official website is here. It's actually a very popular framework. It's developed by GitHub. It powers the editor Atom, this one. GitHub is bought by Microsoft. So it's kind of all the tech giant actually very into those developer tools. So it's a cross-platform apps with JavaScript, HTML, CSS. It's appealing to, it's very attractive to web developers because you can use the same skill set for developing a website to actually develop desktop application. So if you can develop a website, you can develop a desktop application like this using the same skill set, HTML, CSS, JavaScript. So the thing to make JavaScript calling into Rust is this binding library called Neon. There are this is like example. You can basically call into Rust code from JavaScript code. So this is library serve as a purpose. So you can embed this library into JavaScript to call Rust code. Then this is for mobile. We have Android and iOS. Mozilla, which is the main player behind Rust, which is also the main Firefox developer, like actually maintain the Rust language. They have a blog post about how do you get Rust library works on Android. So this is exactly what our application is based about. They have blog posts about to get Android running using Rust libraries. So what exactly means is that we need kind of Rust bindings in the both sides. So on the Rust code side, we need a JNI binding. It's like Java native interface, sort of similar. So you define, if your target is Android toolchain, you define a run function. It's basically the same response and request, just wrapping it as like a JSON. So all those become your input. This is becoming output. But you're wrapping this in a fashion which Android can understand. So Android can call into Rust. So this is the Rust side of the GMI. And on the Android side, you need a Rust bridge. So you load the native library. So this is a Rust library. This local native call is similar, and it's reused in the extension, browser extension. It's also reused in the Android and iOS. So you load this in, and you define this run function. So the input, when we run any command or do the things, it actually goes through those functions. It runs this local native run function. So it calls Rust code and gets results back. So this is the Android side code for make the bridge work. So it's Rust bridge. So Google recently has a 64-bit requirement for all the deliverables, like all the packages, all the APKs, all the bundles. So it's a little bit different and deviate from the original Mozilla post. And this is like a new structure or the required structure if you want to get it published on Google Play. Similarly, for iOS, Mozilla has the post about Rust library on iOS. You need the Rust target, and similarly, I think I forget about the Android. You need the Android target. So here you ending the iOS target in your Rust toolchain. We get here we have this Rust target add. So basically means we have all the iOS target installed, and there's a library called LIPO. Then you can compile iOS binary on the Rust side. Also, you have those wrappers to define the run function on the Rust side. So you define this run function to wrap in your command. You need a run and a free for some reason. And then you need to define a header file for the iOS to actually also create the bridge for the iOS, like a Swift code into Rust code. So this is the headers for including to the iOS side to basically declare those Rust functions as callables from iOS Swift code. So iOS also has like a Rust bridge thing, like header file, and you can import the header file to serve as a bridge. So in the iOS code, you can call the Rust code. Then it's about the core piece of the data storage. So where those nodes goes, where does it actually stored? This is stored in a database called SQLite. And a library called RustQLite is for all the create, read, and delete functionalities. This is a library for manipulates the database. So this is like how do you insert a record in SQL to add a record to your database. So you this is an SQL template. You insert a record, some templates, string replacement. So this is the insert part, like how we add in record. And also there is a search piece, like we type in something we want those only relevant ones. So in the search code is also a string template for creating the SQL command. So here you look like you select all the required columns from the table, which is the node table, and we have a where clause template out as a template out. So this where clause is how the filter actually takes action. It using a statement like title like, URL like, tag like, description like. So that's how it actually happens when we search something here. So it filtered down record to just those matching ones. So that translates to those like statement. So I'm searching on if the title and URL and tag and description has those matching. If it's matching, I'm just showing those records. Then there's a filter on top of the searches or filter based on time. So from the application, we can do something by time series. So all of this record has a time when it's created, and if we filter, if we give it a range, like just this is last year, you can filter the record down to smaller numbers, and you see those numbers change. So that is done similarly by search, by constructing like a filter, also embedded in a where statement. So its filter is the created at columns, which is the date column, timestamp column, by limits them to a range. So this where clause is actually correspond to this action. Like I'm limit date range, so give me back limited results. Currently, there's no update. When record is in, it's either you delete them or it's there. The delete is straightforward. Every SQLite tables has an internal ID which is called row ID. So when I click the red cross button, it's using this statement, delete from the node table where that ID matches what I'm clicking on. So this is the database side. Like every record is stored in SQLite database. We can do the simple CRUD action, CRUD. Then there is a visualization side. So currently this application has a tag cloud. So on this side we have actually show the numbers of how many those tags appear for the selected for this filter on the results. So if you click on the tags actually become your search keyword. To generate those tags and aggregate them, it's also done with combination of database and Rust functions. When we insert a record to make a tag into the database, we strip them, the white space, and we make them non-repeated. We just use comma, separate them. So when you input some tags, this is like some regex to normalize the tag into a standard format to dedupe something and just put comma between them. They use a data structure called linked hash set to do the dedupe and set. Then there is a pagination. So when we're doing something like previous and next, this is called page. So we page to count that every page has 10 record. You need to click on next. It shows your next page record. And how this is done, actually this is not done in Rust. This is done in the specific like upper level language or platform framework. For Android, we implement a logic for making the page. So this you can see this is like return the start, end, and count, which correspond to this string. So it's 3140, the total count within this. When you go to next, it incremental by 10. So this is called pagination, and this is in Android, the code look like this. And in iOS, it's implemented again the same logic, but within Swift. It's very similar. So start, end, and count. In desktop, it implemented in JavaScript. It's a similar thing. Return something, start, end, and count. And the browser extension currently is actually not implemented the similar way yet. So like help is wanted. I have like actually bounty. So there is like a source, bounty source. So developers actually doing this is like you can post like a bug or issue, and hope other people can help you to, if you close them, they get a bounty. Another thing is about upgrade. The data structure, the schema can change during versions. So currently this version is 0.4. We introduced the sync version, but every time when the program runs, it runs an upgrade procedure before doing everything. It checks the version, it upgrades to the newer version, like from 0.3 something to 0.4. So there are upgrade routines. So from 0.3 to 4, there is a major change for UUID column, which is an ID column to identify each record as a unique record with a UUID column. So it's a random ID, but it's unique to every record. Why introduce this is because we use this to synchronize between other device, other record. Like sync your desktop to your mobile, sync desktop to desktop right now using this ID. So we assume every record has a different and unique UUID. Now we're talking about sync. Sync is about synchronize different device, but we want in the end have the same data. If I'm using my desktop, I bookmark some notes, and I'm using my mobile device to book some notes. I want, like, I sync them. There are the extra additional notes on the other device can be on this device. So through the centralized service, you can do that by having your data on a centralized server, as many of the note application does today. But currently, this application, we take a very different approach. If the file is local, we can do a very brutal force insert. So basically, we find where if it's not exist in the other side, based on the UUID, we insert a difference into the other device. We do the similar one vice versa. So both of the device get the same record in the end. This is wrapped into a SQL one transaction. So if you have the file on the same device, you can use sync attach a file, and you will end up getting that file having the same record, and you can copy the file to your other device. But it's not convenient because you need to copy the files to the same machine to copy it out. So we need some better solutions. I experimented with like secure Scalabot, which is a niche social network type of thing. They have a data structure. Basically, every message of every individual become a linked list. So every record, I have an example here. Every record of your message become assigned by the previous message and this message current content. It's like a blockchain. So currently, it's like you have latest message based on your previous message. It's based on your previous message, and then the previous message. So each message become linked list, become like a buffer for a queue for your message. So I have been trying using this like as a like each of the node become SSB message, and I'm trying to have them using this as a buffer to sync them. And this is an example of actually also capture the content for like a page. So you can also like capture the content if you want. And the only problem is it's too heavy, and it's using another dependencies, which is too much for like a lightweight application. So then currently the 0.4 implementation using a library called TARPC, which are coming actually two Google engineers. They start developing a lightweight RPC. So using just lightweight calls between different peers. Using this to define the service as function calls. So when we sync between different devices, they call those functions. We define those calls as Rust functions. This is a macro in the version, this earlier version. So you define this those functions, you wrap them in the syntax. The RPC syntax, I think the newest version, they change it to async. But you define those functions, and you can implement the service as typed functions. So when you check the version, if the other side of the device match your version, you implement a function and you return a feature with a boolean. If you want to have other, like you check the difference, you send this, you define this function, you implement a function, and then you return a future ready. So this turns out to be working. To actually implement the diff, the client and server need to do some work. So they are based on the UUID, and they run both sides. So first run sync to the server and sync from the server. So it's similar to get the difference from both sides. So every record you get by UUID is also translated like a SQL statement. This is preparing to send a note to the other side, and how the diff really happens is by calling the functions like different UUID from the server. So I'm trying to send all I have, my UUIDs as a vector. I send all the UUID I have on my side. I try to get the difference which the other side you don't have. Then I'm asking, give me the ones I don't have. So that's the syncing, basic behavior behind the syncing. Also, it currently seems on lightly Rust, so it's not stable yet, and async await is kind of there. So this is like an example when the server is up. So you can start the RPC server. So on desktop, if you start this, it will give you an address and port, and also like a barcode. So if your mobile device is actually working, do you have that? Okay, so you may want to try this. You can actually scan the code, and probably the thing will come to your phone if you have it. I will try to just only give you the Rust ones because those are smaller. You can prepare the mobile device. We can try if it's working. Let me prepare it. Yeah, If we're on the same network, I think it should work. If we're not,
Okay, I'm
you see. So you click on the left upper icon, scan this code, and left upper icon,
What? Yeah, I know.
and click the sync button.
I'm trying to scan it, but the problem is I think I
Let me see.
can't scan it. It's like it's got cracked.
This is not the same application. You need to go to the app, the local native application. Scan it. Yep. Did you get it?
Okay, so
I think last time we installed it.
yeah,
Yeah. So this one, you click here, and it has this. Then you scan.
you might need to go a little close to it.
Oh, this is. Okay, let's try this.
Got a little cracked.
Okay, that works.
Yeah, cynic.
Okay, so you see you have more.
I
Want to try? This. So this one, did you install the application?
No,
Not yet. Okay. So you can install and scan from that. So his is working. Your did you install it?
No. But I didn't install local native first.
Yeah. So you install it and
Okay.
try scan it again. So his is working, which is good.
You told me to do that 2 classes ago.
Yeah, I tried.
Wait, what was it?
Local native.
Yeah, you can install it
Wait, what was the website again?
in your app store.
Oh, in the app.
Yeah.
Okay.
So you needed a password, right, or something. So you can this is a new password in your app store. You try it also. This is okay. So you can search that or you found the website. And actually this one. But don't worry, when we get there, like we get there.
Wait, what do I use now?
So you get it installed.
Yep, I have local native.
Okay, so you start it.
Oh.
Now, yeah. It may not work. You can still go here.
Okay, yeah. Start sync.
Yeah.
Okay.
And then to finish. So basically, it's give you read the IP address and work. And now
Just
go
in
back.
there.
Yeah, and then if you kind of refresh it,
Okay.
You get the report from my computer. So okay, so that is working. Yeah, so this is kind of the so those numbers are the IP address. If you're on the same network, you have this. You can sync between your device. Like you are at home, you have the same network. You can sync your device to other device.
What do you mean, like sync? Like go to other people's?
So you can have your mobile device bookmarks go to your desktop, right? If you have another device, you can keep them synchronized. Keep your.
Basically mean that I can literally just like link my computer into my phone.
Yeah, keep your data up to date. right?
I have that on my computer.
Yeah, but you take new notes on your phone and you take new notes on your computer. You want your new notes to be appear on another device. This is the way you're doing that.
I don't have local data on my computer.
Yeah, that's what I'm going to do. We're going to do later, right? So there are some experimental things we're doing. Like this is pure text as a note. We can also do. I also tried in my previous experiment to do pictures, to do like a screenshot. So the notes can also be like a picture. If I click that button and so actually I just screenshot the previous desktop. I can do that again. And try to screenshot again. So it's actually kind of loads taking application can take in like different forms, right? Simple one is you take some text, you take some URLs. The more you can actually go to more fancy ones by like taking screenshot or other things, like to basically manage other types of data. You can think about if it's your like pictures or something, you probably can do within kind of the similar fashion. All the component is there technically. So how this is done is for that is basically insert the picture as like a string into the table, into the annotation column, which is not very efficient. So the performance is not that good. And when it's reading it out, it has a data URL to insert image as a data URL. So that's how that appear in this UI. But the performance is not so good, and probably it's actually better to keep them as an image. So this feature is deprecated, removed in the newest version. Okay, so here are some links. We have the Gitter. So actually, I think Reese, you already asked questions on it here, right? So if you have questions, actually, you can find me there. So this is actual slides for the talk, NYC 2019. And I have lectures. So this is actually our lecture for our lecture. The code is also there. Welcome to contribute. So this application currently like works on Linux, like Mac, Android, iOS, but Windows has some issues. So I'd like to get a package on like Windows and get it properly sandbox for Mac App Store. So currently Mac App Store doesn't allow you to modify the folders that have more restrictions. You need to properly sandbox it. There are like to-do list, like the things I wish I could do, bugs, and the bounties. You can always suggest issues. So on the Git lab, I have like issue page. Actually, like a feature requests and the concerns and bugs and issues, create issues. Okay, that's all.